Hello all the students. Today we are going to talk about the least and greatest elements of a poset. We know what a poset is, and when we talk of least and greatest elements, that means we are talking about the least and greatest elements of a poset. Okay, so before I start with what a least element in a poset is or what a greatest element in a poset is, let us see. Assume that we have a poset SR where S is obviously the set and R is the relation on set S. So before we begin with anything, we must be clear with this thing that we have a poset named as S, R. S, R is a poset over here, and S here obviously is the set on which the relation R is formed. Now let's come to the main thing that we were talking about, that is the least element and the greatest element. Okay, least element is also known as the minimum element. When I talk of a least element, what does the definition of a least element say? It says an element X that belongs to set S. Here X is an arbitrary element. That means I am not talking of a specific element. I am taking any element that belongs to the set S. So an element X that belongs to set S is called the least element of set S if for all Y belongs to S, X is related to Y or X, Y exists in the relation. Now let us understand this definition. I say an element X belongs to set S. That means any arbitrary element that belongs to set S would be called the least element of set S if and only if for all Y that belongs to set S. Y is another arbitrary element, and for all such arbitrary elements, for all Y that belongs to set X, X is related to Y, or in other words, the ordered pair X, Y exists in the relation. That means if X is related to every element of the set S, X is an element of set S. Apart from that, for all other elements of set S, which we call as Y, so if X is related to every element of set S, then X would be called the least element. That is X, R, Y. X is related to Y, or in other words, the ordered pair X, Y exists in the relation, which means that X is related to every element. Okay. So this was the definition of the least element. Now let's see what a greatest element is. Again, an element X that belongs to set S. X again here is an arbitrary element that is picked up from the set S. So an element X that belongs to set S is called the greatest element of the set S if for all Y that belongs to S. That means for rest all the elements that belongs to set S, Y are X or the ordered pair Y, X exists in relation. Y are X means Y is related to X. That means all the elements of the set S are related to X, or in other words, the ordered pair Y, X exists in the relation. So the summary of this is that a least element is that element which is related to every other element in the set, and a greatest element is that element to which every other element of the set is related, right? And if at all there is a least element or a greatest element in a poset, there will be only one such element. There will be only one least element in the entire set. Also, there will be only one greatest element in the entire set. A set may not have any least or greatest element. A set may have both a least and greatest element. A set may have only a least element and no greatest element. Or a set may have only a greatest element and no least element. Now we will look at some exercises and see how we can find out a least and a greatest element in a set. So, the first exercise that we will see here consists of a hash diagram like this. Now we have to find out a least element in this and a greatest element in this hash diagram, if at all they exist. So this is a hash diagram. I know a hash diagram is made on a poset, and when I say poset, that means it will be reflexive, it will be transitive, and it will be anti-symmetric. So these three properties this hash diagram will have for sure, because a hash diagram is made for posets, and a poset is always reflexive, always transitive, always anti-symmetric. And since a poset is a relation, so I know that a relation is always directed. So hence this hash diagram will also be directed, and we know that the direction of the relation goes from bottom to top. That is, it will go in this manner, down to up. It will go upwards. So it is directed also, it is antisymmetric also, it is transitive also, and it is reflexive also. Right? Now let us see if there is any least or greatest element in this hash diagram or not. Okay. Now we will start from A. I know there is a relation between A and B, and obviously as the relation goes upwards, so this relation would be like AB. That means A is related to B, B is not related to A. We can say A are B or A comma B, because the relation goes upwards. Okay, so A and B are related. Then I can see that B and C are also related. And when AB and BC are related, and since I know this hash diagram is, this poset is transitive, so it is quite obvious that A and C will also be related. So AB, BC and AC. Okay, now B is also related to D. So since B is related to D and A is related to B, so it is quite obvious that A would also be related to D. Now B is also related to E. And since B is related to E and A is related to B, so it's quite obvious that A is also related to E, because a poset is transitive. Okay, now it is reflexive also. So that means an ordered pair AA, BB, C, C and D, D would also exist. So this is all the pairs that exist in this hash diagram. Okay, so first of all I'll see if there is any least element here or not. Least element, if I call least element as X, then that means ordered pair XY must exist. That means X must be related to every element of the set, or in other words XRY must exist. So let's check if any such ordered pair exists. AB is here, AD, AB is here, AD is here, AC is here, AE is here, and AA is here. That means A is related to every other element of the set. A is related to itself, B, C, D and E. Rest, no such element is related to every other element. Plus, you can only have one least element or one greatest element. So that means if you found that one least element of yours, you do not need to look for another least element since that won't exist. Similarly, if you found one greatest element of yours, you do not need to look for another greatest element since it won't exist. So I found one such least element, and then it's quite obvious that it will be the only least element that will exist. So I can say that which is my least element here? A is my least element. Now let us see if I have any greatest element here. Since I know that as per the definition of greatest element, for all y that belongs to set S, y must be related to x, or the ordered pair yx must exist. That means all other elements must be related to that element. So is there any such element? For B, if I start from A is related to A, then A is related to B, B is related to D, but there is no element which is related to A. Similarly, for B also I cannot find any such element for B also I cannot see that all the elements of the set are related to B. Similarly for C, similarly for D and similarly for E. My condition is that all the elements must be connected or related to that arbitrary element which I cannot see here. So what I can say is that the least element here is A. I have found my least element which is A, but there is no greatest element in this poset or in this hash diagram. So there I could not find any greatest element over here. Okay, now let's see one more example. Okay, now let's look at this hash diagram. We will start again from the lower side. So A is connected to C and C is connected to D. So therefore A is also connected to D. Then A is connected to C and C is connected to E. Therefore A is also connected to E. Then B is connected to C and C is connected to D. Therefore B is also connected to D, and B is connected to C and C is connected to E. Therefore B is also connected to E. Also, as per reflexive, the ordered pair AA, BB, CC, DD and EE exist here. Now, I cannot find any such element which is related to every element in this set. Alright, whether you take A, whether you take B, C, D, E, there is no such element which is connected to every element of the set. Also, if I talk of the greatest element, I cannot find any such element to which all the elements of the set are related here. So therefore, I can say that there is no least element here, and also there is no greatest element here. So it's quite possible that a certain poset may not have any least element or any greatest element. Now let's look at one more example and see if we are able to find the greatest or least element or not. So the diagram is, hash diagram is like this. D, B, A, C. Okay, so let's see if we can find the greatest or least element here. So A is connected to B, A is related to B, and B is related to D. So it's quite obvious that A A is also related to D. Then A is related to C and C is related to D. So it's quite obvious that A is related to D. But since the same pairing cannot exist more than once, so we will not write this again. AD has been written once, we will not write it again. Okay, then I know that B is connected to D and C is also connected to D. So I have written all the relations that exist in this set. Now let us see if we have any minimal or least or greatest element here. So if I talk of the least element, A, of course we cannot forget the reflexive pairing AA, BB, CC and DD. Okay, so A is related to A is related to B, A is related to D, C and A is related to D. So therefore I can clearly see that A is one such element which is related to all elements of the set. Hence I can say that A is the least element here. Now let us see if I have any greatest element here. Okay, so is there any element in this pairing to which all other elements of the set are connected? A is not such element for sure, since it is the least element. B is also not such element, C is also not such element, and D is also not such element. So I can say that there is no greatest element in this poset, but there is one least element, which is A. So we will look at one more last example. Okay, so this diagram is like this. Okay, so first of all we will find out the pairings. Obviously, ordered pair AB exists and BD exists. So if AB and BD exist, then it's quite obvious that AD will exist. Okay, then ordered pair DF also exists. So it's quite obvious that AF will also exist. Then ordered pair AC exists and ordered pair CE exists. So it's quite obvious that AE will exist, and then EF is there. So it's quite obvious that CF will be here. Now since A is related to B, B is related to D and D is related to F, so that means AF would also exist. Similarly, A is related to C, C is related to E and E is related to F. Therefore, AF again would exist, which we will not rewrite. Okay, then CD exists, C is related to D and B is related to E. Now let us see if there is any least and greatest element here. First of all, we will try to find the least element here. Of course, again we will not forget the reflexive pairing, that is A, A, B, B, C, C, D, D and E, E. Okay, so let's see if there is any such element which is related to all elements of the set. A is related to B, then A is related to C, then A is related to D, A is related to F, A is related to itself of course, and A is related to F. That means A is related to all the elements of the set. A is related to itself, B, C, D, E and F. Hence I can say that A is the least element over here. Then let's see if we have any greatest element here. Now greatest element means all elements of the set must be related to that particular element. So I can see A is related to F here. Then I can see E is related to F here. Of course, F is related to F. Then Okay, so we've seen A is related to F, E is related to F, C is related to F, D is related to F, and E is also related to F. So A is related to F, then B is related to F, C is related to F, D is related to F, and E is related to F. So that means F is one such element to which all other elements are related of this set. So I can say that F is the greatest element over here. So this is how you can easily find out the least and greatest elements in a poset.